Okay, let's see how the knowing how to use complex numbers will help us solve some of these quadratics, which in the past we normally would just say there are no real answers to it. Okay, so example 4, we can solve either by completing the square quadratic formula, doesn't matter. I guess I'll do this one both ways. Okay, let's complete the square first, because it's simple. Move the 5 over to the right. Half of 4 is 2. 2 squared is going to equal 4. So that term is going to be on either side. Factoring to a binomial squared, we get x plus 2 squared equals -1. Okay, now we're going to square root both sides. And now I don't want to leave -1 as square root of -1. I can rewrite it as I. Moving the 2 over as well, I get my final solution, which is x is going to equal -2 plus or minus I. Okay, so this one has two imaginary solutions here. If you were to graph x squared plus 4x plus 5, it would be, the parabola would be above the x-axis. It wouldn't have any real intercepts, but it does have imaginary solutions. Okay. If you wanted to use quadratic formula, and it's up to you, I'll show you how that works as well. In the quadratic formula, we'll have negative opposite of b plus or minus the square root of b squared minus 4 times 1 times 5. And what do you notice about the discriminant? Okay, you'll have a negative value under the radical. So your discriminant would be negative. This time it's going to be 16 minus 20, or -4. Simplifying here, we've got -4 plus or minus 2i over 2. And then please simplify all the way to -2 plus or minus I. Okay? So when you have the quadratics, you can solve that either way. It doesn't matter whatever your preference is. Okay? So you guys can try example 5 here. I'll pull up the answer in a minute when you're finished trying it. And these also can be solved on the calculator. I'll show you that as well. Let me just I'll write down the solution for this one. I'm not going to do it. I think you guys can handle it. Okay. No, actually, I don't have an answer for it, so let me do it. If you want, you can divide everything by 4 in this problem first, before you both complete the square and do quadratic formula. Okay? Doesn't really matter what you do there. All right, so because these numbers are rather large for complete the square. Okay, so half of 6 is 3. 3 squared is going to give us 9. Make sure we're adding 36 to that side. Okay, so we've got 4 times x minus 3. That quantity squared is going to equal, oh, again, -1. But remember, I have to divide by 4. So I'm actually going to have -1/4 over here. And when I square root that, the square root of -1/4 will equal plus or minus, okay, 1/2 I. And then I can add 3, so I get x equals 3 plus or minus 1/2 I. Now if you're solving that with the quadratic formula, okay, that's going to yield 6 plus or minus I all over 2. Same thing, okay, but just a different look. Doesn't matter which one we use. Okay, now real quick on the calculator, if you have the application, which I think most of you have, the poly smelt one. Let me scroll down here for you. Alpha P. The second one, the poly smelt 2, you can actually put your answers in the A plus BI as well. So let's check that one we just did. Under poly root finder, here we go. The second line we can put in A plus BI format and go to next. And let's check that last one. it was a coefficient of 4. Our a value is 4. The b value is -24. And the c value was 37. Let's see what we get when we solve that. There we go. 3 plus 1/2 I and 3 minus 1/2 I. Okay? So this will give you the I solutions. Now look, if it's, radical 7I, it's not going to give you radical 7. So you still, again, need to show all your work when you're doing these problems. Okay? All right. Now we don't have a whole lot of time in here to take a look at the history, but sometimes these imaginary numbers do get a bad rap because I think really it's because of the term imaginary. So a lot of scientific fields, some of you guys are going to be in advanced physics next year, and when we look at some vectors, they operate along the same premise of like a plus bi part to the number to the values. So there are a lot of more fields that are using complex numbers, and again, I equals negative square root of 1. The square root of -1 is just the way of notating it. Okay. If we have time later in the year on one of these long periods, I would like to do a little lesson on fractals, because fractals are generated by complex numbers and by the computers, and they're really cool to look at and to watch how they're actually graphed and generated. I didn't really talk about how to graph complex numbers, but we just really need them in this chapter to know how to solve quadratic. So it's kind of a quick lesson. Hopefully you talked about some of this other stuff back in Algebra 2. Okay, all right, that's it for today. I'll see you guys tomorrow.